Welcome back. In the last video, we discussed some options to improve our model from a model perspective, and namely, we're trying to improve it so that the predictions are better, so that the patterns it learns better represent the data, so we can separate blue dots from red dots. And you might be wondering why we said from a model perspective here. So let me just write these down. These options are all from a model's perspective because they deal directly with the model rather than the data. So there's another way to improve a model's results is if the model was sound already. In machine learning and deep learning, you may be aware that generally if you have more data samples, the model learns or gets better results because it has more opportunity to learn. There's a few other ways to improve a model from a data perspective, but we're going to focus on improving a model from a model's perspective. So, and because these options are all values we as machine learning engineers and data scientists can change, they are referred to as hyperparameters. So a little bit of an important distinction here. Parameters are the numbers within a model. The parameters here, like these values, the weights and biases, are parameters, are the values a model updates by itself. Hyperparameters are what we as machine learning engineers and data scientists, such as adding more layers, more hidden units, fitting for longer, number of epochs, activation functions, learning rate, loss functions, are hyperparameters because they're values that we can change. So let's change some of the hyperparameters of our model. So we'll create circle model v1. We're going to import from nn.module as well. We could write this model using nn.sequential, but we're going to subclass nn.module for practice. Why would we use nn.sequential? Well, because as you'll see, our model is not too complicated, but we subclass nn.module. In fact, nn.sequential, so if we write here, nn.sequential, is also a version of nn.module. But we subclass nn.module here for practice, and for later on, if we wanted to, or if you wanted to make more complex models, you're going to see a subclass of nn.module a lot in the wild. So the first change we're going to update is the number of hidden units. So out features, I might write this down before we do it. Let's try and improve our model by adding more hidden units. So this will go from 5 and we'll increase it to 10. And we want to increase the number of layers. So we want to go from 2 to 3. We'll add an extra layer and then increase the number of epochs. So we're going to go from 100 to 1,000. Now, we're going to put on our scientist hats for a second. What would be the problem with the way we're running this experiment? If we're doing all three things in one hit, why might that be problematic? Well, because we might not know which one offered the improvement, if there is any improvement, or degradation. So, just to keep in mind going forward, I'm just doing this as an example of how we can change all of these. But generally, when you're doing machine learning experiments, you'd only like to change one value at a time and track the results. So that's called experiment tracking in machine learning. We're going to have a look at experiment tracking a little later on in the course, but just keep that in mind. A scientist likes to change one variable of what's going on so that they can control what's happening. But we're going to create this next layer here, layer 2, and of course it takes the same number of out features as in features as the previous layer. This is 2 because why? Our X train has, let's look at just the first 5 samples, has 2 features. So now we're going to create self layer 3, which equals nn.linear. The in features here is going to be 10. Why? Because the layer above has out features equals 10. So what we've changed here so far is we've got hidden units previously in V0 of this model was 5, and now we've got a third layer, which previously before was 2. So these are 2 of our main changes here, and out features equals 1 because, why? Let's have a look at, speaking of why, our y is just one number. So remember, the shapes, the input and output shapes of a model is one of the most important things in deep learning. We're going to see different values for these shapes later on, but because we're working with this data set, we're focused on 2 in features and 1 out feature. So now that we've got our layers prepared, what's next? Well, we have to override the forward method because every subclass of nn.module has to implement a forward method. So what are we going to do here? Well, let me just show you one option. We could go Z, which would be Z for logits. Logits is actually represented by a Z, fun fact, but you could actually put any variable here. So this could be x1, or you could reset x if you wanted to. I just look putting a different one because it's a little less confusing for me. And then we could go update Z by going self layer 2, and then because Z above is the output of layer 1, it now goes into here. And then if we go Z, again, equals self layer 3, what's this going to take? It's going to take Z from above. So this is saying, hey, give me X, put it through layer 1, assign it to Z, and then create a new variable Z or override Z with self layer 2 with Z from before as the input. And then we've got Z again, the output of layer 2 as the input for layer 3. And then we could return Z. So that's just passing our data through each one of these layers here. But a way that you can leverage speedups in PyTorch is to call them all at once. So layer 3, and we're going to put self dot layer 2, and this is generally how I'm going to write them, but it also, behind the scenes, because it's performing all the operations at once, you leverage whatever speedups you can get. Oh, this should be layer 1. So it goes in order here. So what's happening? Well, it's computing the inside of the brackets first. So layer 1, X is going through layer 1. And then the output of X into layer 1 is going into layer 2. And then the same again for layer 3. So this way of writing operations leverages speedups where possible behind the scenes. And so we've done our forward method there. We're just passing our data through layers with extra hidden units and an extra layer overall. So now let's create an instance of circle model v1, which we're going to set to model 1, and we're going to write circle model v1, and we're going to send it to the target device because we like writing device agnostic code. And then we're going to check out model 1. So let's have a look at what's going on there. Beautiful. So now we have a 3-layered model with more hidden units. So I wonder if we trained this model for longer, are we going to get improvements here? So my challenge to you is we've already done these steps before. We're going to do them over the next couple of videos for completeness. But we need to what? Create a loss function. So I'll give you a hint. It's very similar to the one we've already used. And we need to create an optimizer. And then once we've done that, we need to write a training and evaluation loop for model 1. So give that a shot. Otherwise, I'll see you in the next video. We'll do this all together.